really need to think about the sustainability because the field is changing like every day. So if you grab something, knowledge today, and by the time you become really, really efficient that is gone, right? So what I'm coming at, that fundamentally some of the verticals which are fundamental to data science, you need to learn that really, really well, which will never change, right? That you need to learn very well. So if you are an engineer, identify in your field what you are really good at and never lose that just because you are becoming data scientist. If you're a statistician, learn statistics well. So at least one vertical you really need to be good at, apart from data science. Data science is a cherry on the cake. It's not the cake. Okay? If you do that, then sustainability part is taken care of. Anything new coming up, you can pick up because you are good at something. And down the road, one of these things will be needed, right? And some of the identified verticals like that, computer science is one, statistics is one, economics is one, math definitely. Nowadays, a lot of things coming up on the psychology, sociology, behavioral science of it, right? So be good at one of those things. That's one thing I would say. We talked with Ramesh quite a bit, and one of the issue was maybe when you come initially, learn a little bit of statistics, right? So that's the first thing, learn that, okay? Second thing is, what are the challenges are there for you while in this next 9 months, right? Or 9 months, where these people are going to grill you and make you learn. Let me give you an idea about what are the kind of challenges from data comes in. I'm not talking about analytics yet, but kind of data waiting for you. Right? So most of the analytics as of now has dealt with data which is generated by human, which is by us, right? I mean, it may be collected through a machine, but at the end of the day, it's generated by us. I swipe a card, you are seeing a data which is from the POS machine, but it's generated by me. And that's where analytics is a little bit easy. Where it's going is now data is going to be generated by, let's say, a robot. That's where analytics is very tough, right? So I'll try to explain what I mean. And this I was not quite aware until I was exposed to a particular problem came on my way. So there is a robotics company in Bangalore. They got a client from China on a car company, manufacturing unit. So they're struggling. So they took me out there. So we gone there, and it's basically the entire manufacturing unit is no light because it's all robots moving around. So they don't need lights. And in the robot, they have one green light and one red light. So green light means the robot is performing well, and the red light is it's somewhere having some malfunctioning. And if the malfunctioning happen, then the robot itself figures out who is the right engineer to call, and they'll call the guy. So far, it's great. Here comes the problem. So the company asked me, can you develop a predictive algorithm which will tell me when any of my robot will go off? So that instead of wasting time for the robot to call the engineer, I can have an engineer within 1 hour time of that robot gone off. If it's done by a human-generated data, it's relatively easy to deal with. But because it's getting generated by robot, it's extremely tough to predict. Any reason why? You don't need to know analytics for this. Well, not behavior. The issue is as follows. If you ask a human to do the same thing 2 times, exactly same environment, there is a variation. Maybe very tiny variation, but there is a variation. When a robot does it and it's in function, there is absolutely no variation in the data. You tell the robot to do the same thing again and again and again, with huge amount of precision, the output will be same. If all your data in that Excel sheet looks same number, there is no uncertainty. If there is no uncertainty, you cannot predict anything. Why can I predict? Because there is uncertainty in the data, right? So this is coming on your way. So human-generated data slowly going to be less. And robot generated, I don't use the term machine generated data, but because in some way we all produce a machine generated data. So that is one aspect of data coming on your way, right? So this is, even in the 1 year back, I was not thinking that efficiently until I hit upon on this problem. And it's a complicated problem from that angle, right? But that's where it is going. You understood the problem, right? Then comes, this huge euphoria of big data, which all of you know. And a lot of the times, all of you may be thinking big data means a lot of data. Maybe, maybe not. Big data means also sometimes when you do not have any data. Right, for example, Samir was showing this example of car standing in front of retail mall. It's actually, it was one of the hedge fund company, some 5 years back started doing that. So their whole idea was, in a localized sector, can I figure out the macroeconomic factors of certain products which are on the stock market of companies. So the one way to look at the demand of that is there are cars coming in and going in, the frequency of parking is a very good proxy of your economic activity of that region. And the economic activity is high, then the economy is doing good on an average. From there I can map back where should I invest my money. If you think carefully, where should I invest my money? That data was not there. From the data, he was creating that data. So big data also like that, right? I will come to a couple of more examples later on. So that's another angle. Then comes another issue called, can I combine big data with small data, which nowadays we are calling smart data. Right, a very big example is, all of you are aware of Trump campaign, but how many of you are aware how they actually did it? The analytics in Trump campaign. Right, so there is a company called Cambridge Analytics, right? Their idea was very simple. I'm focusing mainly analytics part. Their idea was, I will take all the Facebook data. From Facebook, they tied up with Facebook. That's why so much media euphoria was happening on Facebook. They tied up with Facebook, so pretty much you can access the data. And the moment I go to Facebook, it's unstructured data, but it's huge volume. From there, I can know something. But then, from there, they map some aspect that which are the regions I may not get vote. And they did a very pan-US, small psychographic surveys. And the survey named Ocean. And each of the alphabet has a meaning. But these surveys are like 20 people, 30 people, extremely small data. What Cambridge Analytica did is developed an algorithm, how do I merge this small data with this big data when there is absolutely no identifier. And that was the killer. And from there, they tried to predict whether you will vote for Trump, conditional of certain demographics, location, and so on and so forth, right? But this concept is becoming quite popular. Because when big data came, all of a sudden we forget about the behavioral as the surveys, small surveys. So the market research firm, which because of big data was losing ground, all of a sudden they are popping up by saying, I have the small data, now I can combine it and I can become big now in terms of analytics. So that's another aspect of data coming up. And this has inherent statistical challenges in merging. It's not that easy, it's extremely tough. But this also have a huge implication on the policy level to the government. If you look at India government today, there is no dearth of data. The real issue is I cannot combine data. So two departments, let's say income tax and employees provident fund. It's the same guy, but I really don't know who is who. So this is another aspect of the data, right? So that's maybe you will learn. The other thing while you learn, I'll apart from all the sophisticated and very nice algorithms you will learn, there is a very fundamental thing you should put a lot of emphasis, and that's the basis of being successful in analytics is, how do I think about a hypothesis? Hypothesis is the key. The difference between being a statistician, being a computer scientist is, if I'm good at thinking what I want to look at, the business problem and the hypothesis, that's the killer. And that's a clear distinction between an analytics profession and a pure statistician. So learn how to create hypotheses, how to think, talk to the business guys, and that's the training you should pick up. Talk to the business guys, learn to ask the right question, and from there, before you even look at the data, you should have a set of hypotheses you want to look. Because in the era of huge data set, you cannot spend 10 days, 15 days in just looking at the data. Unless you have a solid hypothesis in hand, it's not going to work. So that's a trade you should pick up. That's more thinking. You don't need to be a genius for that. You need to know the domain a little bit. That's a bit of, there is a bit of challenge here because, analytics domain keeps on changing. You move from, let's say you move from Amazon to Flipkart, all of a sudden your terminology changes. They don't talk to each other on the same language, right? So that is a big thing you have to think. Then now I'll come to a couple of the things what is happening from what I'm doing and that, how I can excite you a little bit. So apart from the corporate side, last few years I'm concentrating more on the policy side. But before I go there, even in the corporate side, there is a, new breed of things coming up. So let me take a step back and go back to US. If you look at the top schools in US, top 4 or 5 schools, Stanford, Harvard, MIT, Chicago, you'll be very surprised. One of the best funded analytics lab does not sit in computer science or statistics department. It is not. It is actually in the econ department. The most funded analytics lab of any of these top schools are in the econ department. The reason is simple. So when we talk to these guys, some of the deans and all those, they say, what computer science guys are doing or statistics guys are doing are great, but what we are looking now as the next phase is not to create another computer science algorithm. I want to use what is there already to get benefit out of it. And the usability is in the economics, in the psychology, in the sociology, agricultural department, agronomics, that's what they use it. It's a fascinating way they look at it. So you talk to the economists, they say that, well, I have a fabulous computer science department, they are doing great. Like, there is this huge, last 3-4 year, huge thing coming up in the econ, arena called network economics. If you look at the computer science part of networks, it's a pretty well-established thing. There is nothing new in there. But then the econ guy comes and say, your network modeling doesn't help me because it doesn't take care of the behavior of my consumer. So we did there is a mobile phone company and we did a small experiment. So the main question of the mobile phone company was, I'm going to do an advertisement in the rural sector. But in the rural sector, do I convince the Panchayat Pradhan? Or there is another guy I should convince about my product so that the word of mouth moves around much faster and they get convinced. Who is the guy? A computer science guy will model and will say the Panchayat Pradhan and any other person is probably have equal networks in terms of people in their network. A econ guy thinks, does the age has a differentiation? Does the wealth has a differentiation in the network? So all of a sudden, these things are getting explored much more behaviorally. And that's where a marketing firm wants to know, because they want to know much more behaviorally, because every product now getting targeted on the personal level, right? So even if you look at the fintech companies, some of the fintech lending companies I know in India, or even in US, let me ask you this question. So if let's say today I have online lending company, you are the borrower, what do you expect? You would expect a lot many people coming to borrow from my company because I don't have a good credit history or credit rating, or I would get a lot more who are very good credit history. And they can get loan from anywhere, but just like me, they come to me. Which is the right? Why would my business grow? Okay. You almost agree on that? Okay. Here is the other side. That's what I thought. So there is 3 top lending company in India, on the online lending company, looked at their data, 70% of their consumers are repeat customers, and almost 68% have a credit rating of more than 760. They could get the loan from anywhere. Why does this business grow? It's a transaction cost. I'm asking 6 lakh, 10 lakh max. I don't want to go through the hassle of the bank. I know I will get it. And that's why I know I will get it from this guy also. But the transaction cost, I don't want to go through. It's completely behavioral. Right? So there is a lot of these aspects coming in. I'm pushing this because that's where it will hit you guys also as you move. It's just not algorithm. It's algorithm with all these small silos. You have to learn a little bit of this. So behavioral economics or psychology is a nowadays most US schools top program in analytics. If you see, there is one semester has those kind of programs, right? Now I'll end with some of the examples we are trying to do. Like for example, Samir was talking about Netflix. What does Netflix do? At the end of the day, there is a personalized recommendation, right? Let's map this problem to the policy level. So what is the main issue of India today on the agricultural sector? The yield. The farmer, when they, farming, the yield is not really up to the expectation, right? Apart from the middleman for selling, let's say the yield is not. So can anyone think of, take a Netflix kind of, not algorithm, approach to say, I'm going to develop a personalized recommendation for the farmers. What does this entails to? I can put a chip in the tractor. In some cases in India, that's what we are doing. Put a chip, that chip will tell me everything from soil health card and everything about that particular farming land. And then, based on that data, I can differentiate two farmers on the same locality that what you should do, what kind of fertilizer, what amount you should do, right? There is also a big concept called randomized control trial comes in analytics nowadays. Pricing, for example. I mean, Amazon started it by what they called A/B testing, but it's more than that now. I can give different kind of experiments on the pricing on Amazon, thinking where my friends get a different price than me. That from there I can figure out, what kind of pricing is optimal for a product for how long. So this concept of randomized control trial, I never thought that important because it was in the undergrad days of my BSc statistics, or it was there, and then we forgot. But it's coming back again, right? So a lot of these things, and in India particularly, I would like to say that the policy, data-driven policy making is picking up. It's all over the world it's picking up. And there is a huge scope in these phases. Agriculture is one example. We are trying to do using ISRO satellite image data. ISRO, by the way, has a 0.2 meter resolution data set now. It's that close, right? You take that data, you do this your ML, AI, slice and dice, deep learning, and can you develop a predictive algorithm for your yield? Because if I can predict, I can control the insurance market. Because agricultural insurance is killer today. Right? So a lot of these examples are there. So I guess, I'll be short. There is a beautiful journey you are in. Enjoy it. But, try to learn as much as you can. Inside class, outside class, and don't let yourself learn only algorithm. There will be always somebody who is better than you in algorithm 2 years after you. Right? Algorithm is you'll be always beaten up. Like math. No matter how good I am in math, in my school, when I teach, there will be one guy at least who is better than me. Right? Because it's an age factor. That's okay. So don't concentrate only on algorithm. Learn a lot of other things which are coming. You don't see it right now, but which you will face when you go to that company working. So learn those also, so that as a package you become a very enviable asset. Okay? So I'll just stop.